Hello again. Now we're looking at 4.06 geometric series and applications. Our goals are going to look pretty similar to when we did arithmetic series and applications, but of course now we're looking at geometric situations. So solve real-world problems using the formula for the sum of a finite geometric series. You're going to see that in just a moment and add that to your notes. Derive the formula for the sum of a finite geometric series when the common ratio is not 1. Interesting. Determine the partial sum of a geometric series. Partial sum meaning we're just adding a specific amount of the terms in the sequence. So let's just review briefly what a geometric series is and what a sequence in series is. A geometric series is a series that results from adding the terms of a geometric sequence. So remember, a geometric series means there's a common ratio. To get the next number, you are multiplying, right? So when you go from, in this case, 2 to -6, and then -6 to 8, you're multiplying by the same number every time. And a sequence is a list of numbers separated by commas, while a series is a list of numbers being added together. So here is your geometric series formula. Write it down. Again, notice that S sub n, that looks familiar, but of course this is for a geometric series. And now the question. Find the indicated partial sum of the geometric series. They tell us they want us to find the first 9 terms of this series. Now, we don't see 9 terms, but that's okay. We can figure this out regardless, right? And we do that by identifying the main players because that is what's in the geometric series formula. We would hope we can find all 3 of these without needing an explicit rule or anything else. So a sub 1, do we know that? Yes, they showed us the first term in the series, -3. Common ratio, they didn't tell us specifically, but as long as we see 2 numbers next to each other, and we're told it's a geometric series, we can use our common ratio formula. So take any number in the series, divide by the previous to get R, the common ratio. There it is. And finally, and the number of terms in the series, well, yeah, they told us to add the first 9 terms. So we know everything we need. How nice is that? Let's put it all together. S sub n, the sum of the first 9 terms, is equal to a sub 1. Okay, we have a double negative. Be very careful. N up top, and then double negative again, since R is -9. Now, you could raise -9 to the ninth and then do 1 minus that and multiply times -3 and divide by 10. But these numbers are going to get very large in this problem, so I would encourage you just to put all of this in your Desmos scientific calculator. Just do it very carefully. And if you're using a handheld calculator, make sure to put your entire denominator in parentheses or you'll get the wrong answer. So when you put this entire thing in your calculator, you'll find the sum of the first 9 terms is -116,226,147. And that's what they wanted to know. Moving on. This one hits a little different, and I know you're new to this. We just barely started learning about it. But let's read what's on the board and maybe we could figure it out. It says, the question is, what is the sum of the series? That's a little weird, right? Isn't that vague? Are we missing something? I mean, yeah, over here they told us the first 9 terms, so we knew n right away, right? But we don't know n right now. That's a problem. right? So what do we do? Any ideas? If you don't know what n is, you have two options. Option one, use R, common ratio, to find all the missing terms one by one, piece by piece, then add all the terms of the series to find the sum. Of course, that's easier if you only have a few missing terms, but here we're going from 54 to 486. I don't know how many missing terms there will be. There could be a lot, maybe not, depends on the ratio. In this case, there's actually only one missing term. The common ratio is 3. 54 times 3 is 162. And then multiply that times 3, you get 486, which is our last value. And since we have all of the numbers, just add them together. Now that was pretty simple because there was only one missing, but like I said before, if you have many missing, if that last value is really, really a big number, especially compared to this number before it, you're probably going to want to use option 2, which is using the explicit rule for a geometric sequence and solve for n. Okay? So there is another look. You should already have this in your notes at the explicit rule for a geometric sequence. Okay? So we take that, and what do? Well, a sub n, remember, that represents the last number in the series. And we see that, right? There is no dot, dot, dot after 486. That means that is the last value. So we know a sub n. We know r, 6 divided by 2 is 3. We did that earlier. And a sub 1, yeah, they show us the first value right there. And if you look at the explicit rule, that would leave us with n being the only unknown piece to this equation, which is just what we want. Okay, we plug it in. We have what we want, and now we can simplify by noticing 2 can evenly divide 486 and this 2 here. So these both go away, right? They both become 1s. 486 divided by 2 is 243. And now we get here, which is a very interesting place to be. You will get stuck if you don't pay attention right now. This is a very important part to this. This is one of our rules of exponents, which says if you can get the bases to be the same, you can get rid of them and set the powers equal to each other and take it from there. So fortunately, we found that 3 to the 5th is 243. That requires a little just calculator trial and error. Because you want the base of 3, right? So you would just go, okay, we know it's not 3 squared, probably not 3 cubed. So try 3 to the 4th, 3 to the 5th, and you will find that. Okay? So we can get rid of the 3's and work with the exponents only, add 1 to both sides, n equals 6. We have what we wanted, and now we can put it all together into our geometric series formula, and once again, use our calculator to find that total, 728. What are we being asked here? Well, we see sigma. Sigma is already showing its face. Let's see what else is happening. We're asked to find the indicated partial sum of the geometric series. What is the indicated partial sum? Interesting. We'll figure it out. A sub 1, what's that? You've done this before. Take your formula, plug in the first value on the bottom, that lower limit. 5 squared is 25. A sub 1 is 25. R, what's the common ratio? Well, we don't see a list, but we could find a sub 2, couldn't we? A sub 2 is, well, I'll do it right here. Why not? That's where we're finding our ratio. A sub 2 is the next value. We started with 2, so we're going to go 5 cubed, which I believe is 125. Let me just verify that. Okay, we're in business. And then n. N is how many terms you're adding together. And this is a piece, this is a moment where many people make a mistake. Okay? Think about it. Don't just go, oh, it's 10. And don't just think, oh, it's 10 minus 2. Do the work if you need to. Think about it. If you're starting with 2 and you're going to 10, how many numbers are actually there? 1, 2, 3, 4, 5, 6, 7, 8, 9. We did not see 9 anywhere. Got to be very careful with that. That is going to trip you up if you don't work it out. You can think about it logically, you can write it out like this, but don't just mindlessly think, oh, 10 minus 2. That's not quite accurate because 2 is included, right? Okay, hopefully we have what we need now. Let's see. The sum S of 9, right? We found N is 9. Here we go. Plug in everything we know. There it is. There is a lot going on in these fractions, so just be very careful when you're writing them out and when you're putting them into your calculator. And I made a mistake here, I believe. 1 minus R, yeah, that should be 125. I'm just double checking for a moment. A sub 1. Um, R is not 125. I'm glad I double checked that. And I'm actually glad I made that mistake because a lot of people will probably make this mistake. What were we doing here? We were finding a sub 2. That is not R. I was finding a sub 2 so I could start to write my list, which is, okay, I have a sub 1 of 25, then I have a sub 2 of 125. We don't know the rest. We don't need to know the rest of the numbers. We just use our ratio formula. R is 125 divided by 25, which is 5. That was a crucial part that was missed. I got hung up solving a sub 2 that I forgot to solve for R, but we're back in business. Plug this all into your calculator and you'll get 12,207,025. That's the sum of the first 9 terms. Okay, more practice. The geometric series formula, we're getting familiar with it. Hopefully you're starting to get a little comfortable with it. We're asked to find the indicated partial sum of the geometric series. Where are they indicating that? Right here. S sub 7 means find the sum of the first 7 terms. Do we see 7? 1, 2, 3, 4, 5. No, we don't. Okay. Well, let's use our geometric series formula and figure it out. S sub n, they told us to have the first 7 terms. So n is 7. A sub 1 is the first value in the series. 1 minus, we don't know R yet. Let's see. We have negative, I'll write it out with R here. on the side. R is negative 44 over negative 22. Double negative makes a positive. We have 2. So R is 2. 1 minus 2. I'll put that in parentheses, 2 there. And then N, once again, is 7. Do we have all the parts accurately? Yes. Okay. So once again, calculator from here. It's all about the setup and carefully using your calculator. This will give you negative 2,794. We're getting some good practice in. Remember, one of our goals was real life situation problems, and here we go. Hadaya recently graduated from college with a degree in mechanical engineering. Good for her. And has taken her first job with a large aerospace manufacturing company. Her salary, this is key information, her salary for the first year is, I'm going to even highlight less. For the first year is 83,000. What do you think that represents? It's the first value, the first year. That is A sub 1. In researching the aerospace industry, she has determined that she can expect an average annual raise. That's good. Annual of 10%. Wow. Not bad. So average annual raise. So every year her raise goes up 10%. So that has to deal with the ratio, doesn't it? And this, again, is where a lot of mistakes happen. What do you think it is? Is it, this is 10%, right? Did we move the decimal over twice? So R is 0.10. Well, think about if I multiplied 83,000 times this, would I be getting a raise or a cut? I'd be getting a salary cut, and that is not what's happening. So you need to remember that the ratio here is that she's making 100% of what she made before, right? Plus an additional 10%, which now we can move that decimal 2 places. So R is 1.10 or just 1.1. Don't have to write the 0. That gets missed quite often. And what else is going on? If she receives a 10% raise each year, she is employed with this company. How much will she earn in their first 5 years? So this is year 1. We can use the ratio to find years 2, 3, and so on. So we're looking year to year, and we're adding all those years for the first 5 years. N is 5. And now, time for the setup. And I would strongly encourage you to always label these things before just plugging in to the formula because there's a lot going on, right? The more opportunities for mistakes, the more slowly you want to take things. S sub n is A sub 1. That's a big A sub 1 times 1 minus R 1.1 in parentheses because that value is raised to the power of n all over 1 minus R. Double check as I am. Does it look good? I hope so. So let's see. We're talking about money. This could be exciting. How much money will she make in her first 5 years? $506,723.30. Not bad, not bad. She's not a millionaire, but she's doing all right. And our last problem for the day, determine whether this is a geometric or arithmetic series and then solve. This is different from any question you've been asked today because every time up until now you've been told this is a geometric series. This is a geometric series. That's all we did today. But now you need to determine which one it is or if it's neither. Pause this, try it before I go over it. Okay, the number of new people joining a particular dating site is tripling times 3, right? That's what tripling means right there. That means this is a geometric series. So the number of new people joining a particular dating site is tripling every month. How many new people will have joined the site during 8 months? So we're adding up 8 values. If its growth pattern began when 50 new people began with 50, that's a sub 1, join the new site. So a sub 1, 50, R is the rate, we're tripling, so times 3. We're adding 8 months and is 8. Plug in the parts in the right places and use your calculator to work this out. Okay, again, Desmos Scientific Calculator will be your best friend for this lesson, and that is it for now.